So so now the question is, can we replace this resistor with something else where we'd like to use the small supply voltage VDD, but we'd still like to get a higher gain, right, higher incremental gain, okay. And further, the resistor is, I mean, it should be, it should be, what kind of element is a resistor? Is it passive or active? It's passive, because there is no energy source inside. So, whatever we replace there, right, must also have no energy source inside, okay. So, we would like to replace it by something else, so that the incremental gain is very large, okay, even with a small VDD. Is this clear, people? So, I am going to rub off all this stuff. Alright. So, if you want a lot of incremental gain, alright, remember that the incremental gain is basically the difference in the x coordinates of the point of intersection of the characteristic of the load, which is in the case that we have been discussing, the load is a resistance. So, it is the difference between the x coordinates of the points of intersection of the characteristic of the load with that of the transistor, right. The transistor is not changing. So, basically, and we are back with VDD, alright. So, if you want a lot of gain, basically what you are looking for therefore is a characteristic where it intersects this curve with Vg at that point and intersects the red curve where as close to the origin as possible, correct, okay. So, something like that, correct. Now, if this continued to be a straight line, what comment can we make? It will no longer be passive, because the passive element must have its characteristics in the first and third quadrant, correct. So, if you want this box to be passive, what should the characteristic do? It must do this, and then eventually it must fall to the origin and do something, right, okay. So, now can you think of an element you can put here whose characteristic looks like that? It is an NMOS transistor. Is that clear? And what, so the NMOS transistor, okay, NMOS transistor is 3 terminals. What terminals will you put? So, you need to put the drain, and what should I connect to the gate? What constant voltage? How should I choose this constant voltage? Let me call this VB. How will I choose VB? Remember that this is a very exaggerated picture. In reality, the delta V will be very small. So, the red curve will basically do something like that, and therefore the magenta curve, which is the curve corresponding to the load, must do something like that. All right. So now what? I mean, it's very nice that you guys all figured out that it is an NMOS transistor. Now the question is, what should VB? How should VB be chosen? The current must be so same as in what? What is that same? I know, right? So VB must be chosen such that the current when it operates in saturation is exactly equal to I know, right? So one way of doing that is to basically, yeah. How do you any suggestions on how we can get that I naught, Siddharth? Yeah. So basically, one way to do that is to say, I'm going to use an I naught here. Okay. All right. So when what do you call Vg is the delta V is 0, this is the point of intersection, and the output will be close to when delta V becomes slightly positive. What happens? The point of intersection will move to the left, right? And because the slope, I mean, basically what matters is not the slope of this. I mean, the basically what matters is that the slope of the load characteristic between the red and the black curves must be, it must have as small a slope as possible, correct? Only then will the distance between these 2 points of intersection be very, very large. Is that clear? So, so this basically is called, I mean, even though the load is actually passive, it's called the active load. All right. And as you can imagine, this is an extremely useful technique because it allows you to get a very large incremental gain. You would have to increase the VDD by a large factor, right? Whereas here, by using a transistor, you are able to get a large incremental gain with only a small supply voltage. All right. And remember, on an IC, it's always it's cheaper to have a transistor rather than a resistor. So it basically allows you to get a large incremental gain in a small supply, and that's basically why this technique is very, very useful. Okay. So now, for example, if I now plot say Vg, let me call this Vg naught, which results in I naught. So if I plot Vg versus Vx, how will this characteristic look like? Vg naught results in I naught. Okay. So for what Vg will I get a large incremental gain? I mean, by the way, when you get a large incremental gain, what comment can you make about the region of operation of all the transistors? They all operate in saturation, and the current in the NMOS transistor is the same as the current in the PMOS transistor, correct? That is the only circumstance under which you get a large incremental gain. Is that clear? Alright, now based on this, can you tell me for what Vg will you get a large incremental gain? When I naught flows, I mean the currents flowing in both the transistors is exactly the same, no matter what the region of operation is, correct? If the NMOS transistor is in saturation, the current that flows through its drain is I naught, alright. If the PMOS has to be, I mean the PMOS current has to be therefore I naught. If the PMOS has to be in saturation, what must be its gate voltage? Vg naught. When the magic voltage is Vg naught, what comment can you make? Both the transistors are operating in. What comment can you make about the incremental gain? Therefore, the incremental gain is very high. Is that clear or no? Right? Okay. So, if I mean the incremental gain is simply the slope of the, in this picture, how will you get the incremental gain? If I draw the Vx versus Vg characteristic, how will we get the incremental gain at a given operating point Vg? Slope of the characteristic. So, when Vg equals Vg naught, the slope is, what comment can we make about the slope? Very high. And what about the sign of the gain? Is it negative or positive? Why is it negative? Why is it negative? Looking at the picture, why is it negative? In this picture, what corresponds to the sign of the incremental gain? I mean, what corresponds to the incremental gain? Originally, the operating point was here. When I increase the input voltage from Vg to Vg plus delta V, where is the point of intersection moved? Towards the left. So, it is actually reduced, and therefore, the incremental gain is negative. So, what comment can you make about the slope? Steep negative slope. So, you will see something like this.